If everything we know, everything we see, and everything we call reality is sitting inside the core of a black hole, then the universe around us is not an endless stretch of galaxies, but the interior of an object formed in a place we can never reach. This idea sounds like something that belongs in a late-night conversation or a thought experiment whispered by a theoretical physicist who knows the limits of human understanding. Yet it is one of the most serious ideas in modern cosmology. When a star collapses under its own weight, forming a gravitational well so deep that even light cannot climb out, the event horizon becomes a one-way boundary between the outside universe and the interior world forming within the singularity. If our universe began with the same violent collapse, then the Big Bang might not have been an explosion from nothing, but the moment when matter from a parent universe compressed into a single point so dense and so hot that its internal structure tore itself open, creating a newborn universe with its own space, its own time, and its own physical rules. Inside that bubble, space would stretch outward the way a balloon expands, carrying galaxies with it. And to any beings living there, the expansion would feel like the beginning of time itself. We might be the children of a cosmic chain reaction, with every black hole giving birth to new universes the way seeds fall from ancient trees, each one holding the potential for stars, planets, chemistry, and perhaps life. The walls we call the cosmic horizon might be nothing more than the inner surface of a black hole's event horizon, stretched across unimaginable distances to the point where the curvature of space-time reaches its limit. And beyond that limit lies a realm forever hidden from us, because light from that boundary can never reach our telescopes. The fact that the universe appears to be expanding faster the farther we look could be the signature of the gravitational pull from a world outside our own. A reminder that while we see a cosmos spreading outward, the deeper truth may be that everything is falling inward toward a center we can never touch. And when we study the cosmic microwave background, try to read the faint glow left from our earliest moment, we might actually be staring at the imprint of a gravitational shockwave created in the final instant of collapse that formed the black hole we now live inside. If that is true, then our understanding of space changes completely, because what we call empty vacuum becomes the stretched interior of an object whose mass belongs to another universe entirely. And the laws of physics we measure might simply be the byproducts of how matter behaves when trapped inside the kind of extreme curvature, shaping quantum fields into the patterns we now call particles, energy, and forces. This means that galaxies swirling in place are not just systems bound by their own gravity, but pieces of a much larger internal structure, tiny dancing lights inside a vast chamber carved out by forces we still do not fully understand. All of it suspended in a deeper darkness beyond our horizon. And if every black hole in our universe contains its own internal space, then the cosmos becomes an endless nesting of realities, each one spawning the next in a silent chain of creation reaching beyond the limits of imagination, leaving us to wonder whether the universe we see is just one leaf in a forest without end, each leaf growing from branches we will never see, each branch connected to trunks older than time itself. If this idea holds any truth, then the very structure of our universe takes on a new meaning, because what we call space-time may be nothing more than the stretched interior geometry of an object that formed far beyond our own cosmic horizon, giving rise to a kind of hidden architecture where gravity, matter, and time behave the way they do precisely because they are shaped by conditions outside our universe. When a black hole forms, the collapse creates a region where densities rise so sharply that the normal rules break down, and what lies inside that region becomes completely disconnected from the outside world. Yet mathematics suggests that instead of simply shrinking to a point, the matter can re-expand into a new bubble of space-time, sealed off from the universe that created it. If that is what happened at our own birth, then the Big Bang wasn't truly the beginning of everything, but the opening of that sealed-off chamber, giving us a cosmic interior that has been stretching ever since. The reason the expansion looks uniform in every direction might be because we are observing the inherited symmetry of the gravitational collapse that created our black hole universe, the same way the surface of a balloon looks uniform no matter where you stand. And when we measure the speed of this expansion, noticing that it accelerates with distance, it may not be because of a mysterious form of energy filling space, but because the internal geometry of a black hole stretches more rapidly the farther it is from the center. This becomes even more compelling when considering that the mass of a black hole determines the size of its interior. If the universe seems vast, almost unimaginably large, perhaps that means the parent universe contains stars beyond anything we can comprehend, forming black holes with masses so great that their interiors could hold multiple cosmic volumes like ours, each one hidden behind its own event horizon. This idea also offers a strange but compelling explanation for why the universe appears finely tuned for the existence of stable matter, chemistry, and life. If universes are born inside black holes, then only those with certain physical laws would produce conditions stable enough for stars and eventually life to form, meaning that universes like ours would be more common simply because they're the ones that continue producing black holes capable of giving rise to new universes. In this way, cosmology becomes a kind of natural selection on a cosmic scale, where universes that create more black holes through stars, galaxies, and clusters are the ones that reproduce, while universes that fail to form stable structures simply fade without descendants. And if consciousness arises in one of those stable universes, like ours, then it becomes the observer of a system built from cycles far older than anything life could ever record, leaving us with glimmers of a truth we cannot touch, but can sense in the shape of cosmic expansion, the distribution of galaxies, and the quiet, persistent glow of background radiation humming softly through space. Everything around us may be the internal memory of an event that occurred in a world we can never access, like watching shadows on the walls of a chamber without knowing what object cast them. And each observation we make becomes a piece of evidence that the universe is far more layered, far more structured, and far more interconnected with unseen origins than our senses would ever allow us to grasp.
Even the strange balance between matter and energy, the way gravity shapes everything with such precision, and the remarkable stability of physical constants might be the echoes of that original collapse, frozen into the rules of our universe the moment our cosmic chamber came to life. And while we see galaxies drifting away from us, drifting faster and faster as the distances grow, we might actually be watching the stretching interior of a black hole reaching toward its own form of cosmic adulthood, maturing in a way no observer inside it could ever feel directly, yet leaving behind patterns we can study like fingerprints of a creation story we only partially understand. If we picture our universe as the interior of a black hole, then the limits we see in the sky begin to resemble the same kind of physical barrier described by an event horizon, a surface that traps light from ever escaping to whatever lies beyond. In our case, the cosmic horizon is the farthest distance from which light has had enough time to reach us, but it behaves in a strangely similar way. Beyond that boundary, information becomes unreachable, not because it doesn't exist, but because the expansion of space pushes it away faster than light can cross the gap. To us, this looks like the edge of the observable universe, but in the black hole universe model, this could simply be the inner surface of the event horizon, stretched so far across its interior that no matter how far we look, the boundary always keeps its distance, hiding what lies on the other side. This creates a strange symmetry between the sky above us and the equations describing black holes, as if nature left behind clues about the deeper structure connecting the two. Every galaxy we see drifting away could be the motion of matter following the internal curvature of a black hole's geometry, guided by rules that were set before our universe even opened, shaped by the mass, rotation, and charge of the parent object. And if the parent black hole rotated rapidly, as many black holes do, then our universe could have inherited a built-in directionality, a subtle twist in spacetime that shows up in the way galaxies rotate, the way structures align at massive scales, and even in the faint variations seen in the cosmic microwave background. Some researchers call these alignments the axis of evil, a name that comes from how uncomfortable it feels to admit that the universe might have a preferred direction when most theories depend on perfect uniformity. But if our universe grew from the core of a spinning black hole, then a global spin would make perfect sense, because the interior spacetime created by such an object would naturally carry a kind of embedded rotation. This rotation would be far too subtle for everyday physics but might become noticeable only when we look across billions of light years, where patterns start to hint at something larger shaping the entire cosmic layout. This also raises the possibility that different black holes in the parent universe create different kinds of child universes, each one inheriting its own unique set of physical constants depending on how the black hole formed, how it collapsed, and what kind of matter entered it. In one universe, gravity might be weaker, leading to a cosmos where stars never form. In another, gravity might be so strong that everything collapses too quickly for life to exist. Our universe sits in one of the rare balanced zones, with physical constants precisely tuned to allow atoms to form, stars to burn for billions of years, and life-supporting planets to emerge around stable suns. This delicate balance becomes less surprising if countless universes exist inside countless black holes, because out of an enormous number of cosmic births, a few would inevitably end up with the right conditions for long-term stability. It's similar to how life on Earth emerged from a vast number of chemical combinations, most of which produced nothing, but eventually one path worked and evolution began. If universes function like seeds falling from cosmic trees, then most would disappear without leaving descendants, but universes like ours, full of stars, full of black holes, would become the ones that continue the cycle, generating new universes inside the black holes created by their own stars. This paints a picture of reality where creation is not a single event but an ongoing process, a continuous branching of universes over unimaginable stretches of time, and we happen to live in one of the branches where matter settled into a pattern stable enough for galaxies to grow and intelligent beings to eventually wonder how it all began. And while we measure cosmic expansion with satellites, telescopes, and equations, what we are really measuring might be the internal breathing of a cosmic chamber carved out long before our existence, growing in size because it sits inside a larger universe whose gravitational influence continues to shape its evolution. The idea becomes even more striking when we consider that black holes in our universe may themselves contain new universes, each with its own timeline, its own physics, and potentially its own observers looking up at their own sky, wondering the same thing we are now, unaware that their entire reality exists as a small internal structure inside a star that died in a universe beyond their reach. Every black hole in our night sky might be the birthplace of a new cosmos, each one carrying the imprint of the universe that formed it, while we, inside our own, cling to clues left by the collapse that once happened in a place we will never see. And this perspective changes the meaning of our cosmic horizon, not as a limit of existence, but as a limit of communication, a quiet reminder that the structure holding our universe together extends into realms forever sealed from us, while we drift through the vast interior of a structure that is both our home and our boundary, shaped by forces older than our own time. If our universe is truly the interior of a black hole, then the singularity at its center becomes something far more profound than a point of infinite density. It becomes the original seed of everything we know, the birthplace of every law that governs reality, and the silent core around which all of existence expands. In traditional descriptions, a singularity is a point where our mathematics fails, where gravity becomes infinitely strong and spacetime curves without limit, but in the black hole universe model, the singularity may not behave as a literal point at all. Instead, it might be a surface or a region where the collapse from the parent universe transitions into expansion for the child universe, meaning the moment we call the Big Bang was actually the moment when that collapsed material began stretching into new spacetime. This transition could have created the enormous burst of energy we detect as the primordial fireball, not because something came from nothing, but because something came from a state of compression so extreme that its re-expansion released energies far beyond anything that could happen naturally inside a stable universe. This would explain why the early universe was so hot and dense while also avoiding the paradox of creation from nothing, replacing it with a simple continuity. Matter compresses in one world, then stretches into form in another. And as this stretched interior grows, it carries the imprints of that collapse, which we now observe as faint asymmetries in the cosmic microwave background, tiny variations in temperature that scientists use to map the earliest structures in the universe. These patterns might be the scars of a collapse we never witnessed, encoded into the first second of our existence, frozen in light that has been traveling through space for nearly 14 billion years. Even the inflationary expansion, the rapid, almost instantaneous growth of the early universe, could be tied to the geometry of black hole formation, because such extreme compression followed by release could naturally produce a burst of expansion far faster than ordinary physics would allow. And the reason that inflation eventually slowed might simply be that the internal spacetime of the black hole stabilized into its long-term expansion pattern, giving rise to the universe we now observe. Gravity, too, might reveal clues about this hidden parentage, because the way mass curves spacetime in our universe matches the equations for how the interior of a black hole behaves when stretched to enormous scales. When we see galaxies bending the path of light around them, or watch stars orbit invisible centers in perfect ellipses, we may unknowingly be witnessing the same geometry that shaped our universe from the very beginning. Dark matter, with its unseen gravitational influence, might not be mysterious particles at all, but a side effect of this inherited geometry, a subtle curvature embedded into spacetime from forces outside our horizon, left over from the way matter collapsed before our universe was born. And dark energy, the force driving the acceleration of cosmic expansion, could be the natural behavior of an interior space still shaped by its connection to a parent universe, continuing to expand because the geometry of a black hole demands it. We see it as a mysterious pressure pushing galaxies apart, but it could simply be the product of living inside a structure where space grows naturally as part of its internal shape. In this model, the universe doesn't need a hidden energy. It expands because expansion is built into its foundation. Even quantum mechanics might find new meaning here, because the strange behavior of particles, their uncertainties, their tendency to exist in multiple states at once, their entanglements across distances, could be the shadows of deeper structures connected to the collapse that formed our universe. Everything we observe may be shaped by hidden conditions at the boundary we cannot see, like ripples on the surface of a pond whose depths we can't measure. And this means our universe might not be an isolated bubble, but part of a vast cosmic hierarchy where each layer gives birth to the next, creating a structure so enormous that human language has no word capable of describing its scale. When we stare into the night sky, we might be looking across the interior of a black hole that formed billions of years ago in a universe that itself could be inside another, with each layer connected by the same silent machinery of collapse and rebirth. It paints a picture of reality where nothing truly ends and nothing truly begins, where existence is a continuous chain of universes branching from one another like endless roots spreading through the dark soil of eternity, and we are just one branch among countless others. If this cascading structure of nested universes is real, then every black hole in our cosmos becomes far more than a mysterious void swallowing matter. Instead, each one becomes a gateway through which new universes may arise, each with its own version of physics, its own expansion, its own tapestry of stars and galaxies developing according to the initial conditions set by the collapse that formed it. Inside those black holes, space could stretch and expand the way ours does, creating entire cosmic interiors beyond our reach, each one separated from the others by boundaries that no light can ever cross. To us, a black hole looks like a dead end, an object that compresses everything into a darkness no signal returns from. But from the inside, that same collapse could be the beginning of a new cosmic landscape where time flows forward, where matter gains form, and where new observers someday look upward and wonder about their own origins. The idea that our universe may be just one room inside an incomprehensibly large mansion of universes reframes everything we think we know about existence, because it means our cosmic home is not unique but one of many, each carved out by its own gravitational collapse. And if this is true, then the familiar laws of nature that govern our daily lives, gravity holding us to the ground, light moving at a constant speed, atoms forming stable structures, become the inherited rules of our cosmic environment, specific to our universe the way weather patterns are specific to the atmosphere of a single world. Beyond our universe, other sets of rules might hold, shaping realities that function in ways our minds cannot picture, perhaps with forms of matter unknown to us, or forces that operate without any resemblance to what we see. Yet each universe might still follow a deeper pattern dictated by the overarching structure that gives rise to all of them, a pattern rooted in how matter collapses, how gravity operates at extremes, and how space-time behaves at its most compressed. If such a structure exists, it would explain the quiet regularity we observe in the cosmic distribution of galaxies, the smoothness of background radiation, and the uniformity of the laws we measure across billions of light-years. All these things might be the signature of a universe born from a stable collapse, one that produced smooth internal geometry and allowed stars and planets to shape themselves without being torn apart by chaotic physics. And when scientists talk about the fine-tuning of the universe, how the strengths of forces and masses of particles seem perfectly balanced for life, this nested universe picture offers a natural explanation, because out of countless universes forming inside black holes, only those with stable physics would grow large enough to host stars long-lived enough for complexity to emerge. We live in such a universe not because it was designed, but because only universes like ours survive long enough to produce observers capable of asking questions. It becomes a kind of cosmic Darwinism, where universes capable of forming black holes, capable of producing new generations, are the ones that propagate through this eternal chain. This also means our own universe is still participating in this chain right now, as black holes continue to form inside collapsing stars, each one possibly triggering the birth of a new space-time domain sealed off from us, carrying forward rules influenced by our own. Our universe, vast as it appears, might already contain the seeds of generations yet to come, each one hiding behind an event horizon somewhere in the distant night sky. We may never reach those universes, never communicate with them, never observe them directly, yet the possibility that they exist reshapes our understanding of what it means to exist at all. And while our instruments measure the steady expansion of our universe, mapping the drifting of galaxies across cosmic time, what they are really charting could be the gradual unfolding of this internal space, a space whose shape and behavior were set long before our earliest moment, determined by forces rooted in a collapse we cannot witness. Everything we know, stars, planets, oceans, living creatures, human thought, has grown within this interior, shaped by a history older than the Big Bang itself, a history written in the collapse of a structure beyond our comprehension. And in the silence between the stars, hidden in the faint background radiation that fills the sky, there may still be traces of that ancient event, relics of a moment when our universe first stretched open inside the dark core of a massive gravitational well in another universe whose light will never touch us. And yet, the most unsettling possibility is this: if our universe truly sits inside the event horizon of a parent black hole, then everything we perceive, every law of physics, every quantum rule, every constant that seems finely tuned for life, might simply be the internal conditions of that black hole's geometry, not the result of cosmic design or randomness, but the natural byproduct of gravitational collapse in a higher dimensional realm. That means the speed of light, the strength of gravity, the mass of the electron, the exact amount of dark energy stretching our universe apart. All of it could be inheritance, passed down from the star-sized or even galaxy-sized object that collapsed to form the black hole that became our cosmos. Our universe might not be a standalone creation at all, but a continuation of something older, something larger, something that existed long before time began for us. And if that's true, then black holes in our universe might be doing the same thing. constantly collapsing into new universes of their own, each one sealed off from ours, each with its own versions of physics, its own stars, its own galaxies, its own civilizations wondering the same terrifying question. Are they simply the children of another universe too? In this view, the multiverse is not a scattered collection of bubbles drifting through an infinite void, but a branching family tree, where every black hole is a doorway to a new reality, where every supernova is a cosmic pregnancy, where creation is not a singular event, but a cycle, endlessly repeating, endlessly evolving, endlessly producing universes that may never know their origin. And perhaps the most haunting part is this. If our universe is inside a black hole, the parent universe may still exist beyond our unreachable horizon, vast and ancient, unaware that within one of its collapsed stars, an entire cosmos is unfolding. A cosmos where life emerged, where intelligence arose, where beings like us look up at the night sky and try to understand the truth of where we came from, not realizing that the answer might be hidden behind an event horizon we can never cross. But if we truly are living inside the interior of a black hole, then the structure of our cosmos, its shape, its destiny, even the flow of time itself, is governed by forces we cannot directly witness, forces rooted in a higher dimensional space that remains forever outside our reach. Inside a black hole, space does not behave the way we expect. It stretches, warps, and funnels inward toward a central core where density becomes unimaginable, where the curvature of space-time approaches infinity, where the mathematics of our universe begin to fail. Yet some physicists argue that the singularity we imagine might not be a single catastrophic point, but rather the starting surface of a new universe, the spark that ignites a fresh expansion on the inside while the black hole remains stable on the outside. In this model, what we perceive as the Big Bang wasn't an explosion from nothing. It was the moment the internal space-time of our parent black hole began to inflate, expanding away from the singularity surface the same way a newborn universe stretches rapidly after its violent birth. And as strange as it sounds, this perspective explains mysteries that have puzzled scientists for decades. Why our universe appears flat, why its temperature is uniform across regions that should never have touched, why the laws of physics are so precisely balanced as if fine-tuned for the existence of complexity. All of these conditions would naturally emerge from the geometry inside a black hole, where initial states are smoothed, stretched, and reset during collapse. And it forces us to confront a profound, almost uncomfortable possibility that the universe we call home might not be the fundamental reality, but merely one chamber in a much larger architecture, a hidden hallway in a cosmic mansion that extends far beyond our horizons, built on layers of creation we will never see. If this is true, then our universe is both vast and small, infinite from the inside, yet contained from the outside like a pearl within a cosmic shell. And somewhere beyond that shell, in the unreachable expanse of the parent universe, the collapse that created us might have been just another event, unnoticed, unremarked. A star dying, a core imploding, while inside that fall, an entire universe burst into existence. And if our universe was born inside a black hole, then every moment we have ever experienced, every galaxy, every star, every atom, is part of a gravitational bubble whose boundaries we can never breach, a cosmic womb sealed by, an event horizon that marks the edge of everything we can ever know. Beyond that horizon, time behaves like a one-way downward slope, locking all information inside, preventing anything from escaping back into the universe that birthed it. From our perspective, the horizon is simply the limit of the observable cosmos, a spherical boundary expanding at the speed of light, but from the outside, it would look like a frozen shell, a silent sphere suspended in a larger, older universe governed by physics we cannot access. This duality, one interior, one exterior, creates a breathtaking image. A universe that feels endless from the inside yet exists as just one object among countless others from the outside. And this leads to a staggering implication. If black holes create universes, then every black hole in our universe could be a cradle of creation, each one harboring its own expanding cosmos inside, each with its own laws, constants, particles, and timelines shaped by the collapse conditions that formed it. In this grand hierarchy, reality becomes a branching tree of universes growing from the deaths of stars, each generation giving birth to new physics, new possibilities, new forms of existence. Our universe, too, would be part of this lineage, the product of a previous universe's collapse, inheriting dialed-in parameters from the parent cosmos like the mass of the electron or the strength of gravity, passed down not through genetics but through the deep geometry of spacetime itself. And if this cosmic evolutionary process is real, then the existence of life isn't an accident. It is a byproduct of universes that favor stability, structure, and complexity. In such a multiversal forest, only the universes with finely balanced laws grow large black holes capable of producing new universes. In other words, we exist because our universe is the type that reproduces well, and the laws that allow us to exist may be the very laws that allowed the black hole that created us to form in the first place. And if our cosmos truly formed within the core of a collapsing star inside a parent universe, then the very structure of our spacetime might still carry the fingerprints of that violent birth, hidden in the smoothness of cosmic expansion, the uniformity of the cosmic microwave background, and the mysterious presence of dark energy that continues pushing everything apart. The outward acceleration we observe could be nothing more than the momentum of the collapse that created us, still echoing through every atom and galaxy, an ancient shove from a catastrophe we can never witness. Even the geometry of spacetime might be subtly curved in ways that reveal we occupy the inside of a larger gravitational well, with the apparent flatness of the universe masking a deeper curvature visible only from the outside. And if intelligence evolves within such universes, civilizations like ours may look up at their stars and wonder why the laws of physics feel so precisely tuned, never knowing that these laws were shaped not by chance but by the cosmic conditions of a collapse happening eons ago in a universe unimaginably distant. In this vision, black holes are not merely destructive endpoints but cosmic engines of renewal, each one sculpting the rules of existence inside it, creating a new arena where matter, time, and consciousness can rise again. Imagine then the philosophical weight of this idea. Our universe is not the beginning but a middle chapter in a lineage of creation stretching back through an unknown ancestry of collapsed stars, each universe layered inside another like a nesting doll of reality. From the outside, our entire cosmos might be nothing but a microscopic region of warped spacetime, a place so small and insignificant that it would never be noticed by the beings of the parent universe, just as we overlook the quantum fluctuations inside atoms. And yet within this tiny pocket, there are galaxies, civilizations, dreams, tragedies, triumphs, and the entire tapestry of human history, all unfolding in what might be nothing more than a speck of gravitational dust to the world beyond. If this is true, then the question of where did everything come from becomes even more profound, because the ultimate origin would lie beyond our cosmic horizon, forever inaccessible, hidden behind layers of universes stacked upon universes like reflections in endless mirrors. And as scientists push deeper into this idea, they begin to explore the strange possibility that the rules of physics inside our universe, the values of fundamental constants, the strength of gravity, the behavior of particles, might all be inherited from the conditions of the star that birthed us, encoded the same way a child inherits traits from a parent. If the parent universe had stars far larger and more chaotic than ours, then the black holes they formed could spawn daughter universes with even more dramatic physical landscapes. Some might collapse instantly, unable to sustain stable atoms. Others might expand too rapidly for galaxies to take shape. Thousands could be barren deserts of physics where nothing, not even the simplest molecule, could ever form. But a few, very few, might achieve the delicate balance required for complexity to rise, allowing stars to ignite, planets to form, and life to awaken. This means our universe could be one rare survivor in an endless evolutionary chain, shaped not by randomness but by the gravitational environments that preceded us selected by the simple fact that universes capable of producing black holes are the ones that replicate. In this breathtaking view, cosmology becomes a kind of natural selection on a cosmic scale, where universes that generate more black holes are the ones that produce more offspring, continuing the cycle indefinitely. And if that is true, then perhaps the very existence of life, intelligence, and consciousness is not a cosmic accident but a side effect of this generational process, because a universe stable enough for complex life is also stable enough to form long-lived stars that eventually collapse into black holes. From this perspective, we are not outside the process. We are a direct product of it, observers watching the mechanism of our own origin without realizing we are part of the machinery. It suggests that every black hole we discover, every invisible well of darkness lurking in galaxies, is not a dead end, but a doorway to a new universe, each one silently carrying forward the legacy of its parent, while forging its own path through the laws of physics. And as we map the sky and catalog these objects, we might be unknowingly charting a vast family tree of reality, a genealogy of universes connected not by blood, but by gravity, collapse, and creation. And once we begin to think of black holes not as dead ends but as the cosmic wombs of new universes, the entire structure of reality takes on a radically different shape, one where every galaxy becomes both a cradle of stars and a hidden factory for universes yet unborn, each black hole a silent chamber where space-time twists so violently that our physics can no longer trace the path forward. Inside that hidden interior, completely cut off from us by the event horizon, the collapse might slow, halt, or even reverse depending on the underlying laws, and in that reversal could lie the spark that inflates a new universe from a singular seed. This means that the Big Bang itself may have been the result of such a turnaround. A collapsing star in a larger cosmos reached its limit, flipped into expansion, and birthed all the space, matter, and energy that would eventually become our home. And this idea begins to explain some of the deepest puzzles that standard cosmology struggles with: why the universe is so uniform across distant regions that have never had time to interact, why the fundamental constants of nature fall into the narrow range that allows stable atoms and long-lived stars, and why the early universe expanded so smoothly instead of tearing itself apart. If it came from a parent universe, then the conditions at birth were not random but inherited, shaped by the collapse that occurred before the bounce. And when you think of it like this, our universe becomes less like an isolated miracle and more like a chapter in a much older and ongoing story, a story where each universe emerges with its own physical traits and evolves under its own rules, only to give rise to the next generation through the birth of black holes. With this framework in mind, the idea that we are living inside a black hole becomes less absurd and more logical, because from the inside, a black hole, stretched by rapid expansion, may appear exactly like a universe. Regions racing away from each other, horizons defining what can and cannot be observed, and space-time shaped by the energy trapped inside. In fact, if you look closely at the equations governing the geometry of black holes and compare them to the equations describing the expansion of the cosmos, you find patterns, uncanny similarities that suggest the boundary between inside and outside might not be so clear. It raises the unsettling thought that the entire visible universe could simply be one region inside a larger structure we have no way of sensing, trapped behind a horizon created long before the first star lit up. And if that's true, then everything we call reality, the galaxies, the voids, the cosmic web, might exist inside a cosmic bubble sealed off from its parent by a barrier we can never cross, leaving us forever cut off from the environment that produced us. And once you begin imagining our universe as a sealed bubble born inside a larger cosmic environment, the questions become even more unsettling, because if we truly emerged from a black hole in a parent universe, then the structure that surrounds us, the great cosmic horizon we see as the limit of observation, might simply be the inner wall of our own event horizon, stretched across unimaginable distances by the inflationary burst that occurred at our birth. Everything we perceive as the edge, everything that seems to mark the boundary of what light can reach, could merely be the last visible trace of that expansion, a bright shell frozen in time that hides the truth of our origin. And this would mean that the parent universe, with all its galaxies, stars, and structures, is still out there beyond that boundary, completely inaccessible to us in the same way anything on the outside of a black hole is forever inaccessible to what lies within. What's more, it suggests that our universe's isolated nature, the way space expands faster than light at great distances, the way galaxies slip away into darkness, is not an accident but an inherent feature of being trapped inside a horizon. The expansion may simply be the stretching of interior spacetime caused by the extreme gravitational forces at birth, forces so intense that the initial singularity did not collapse but erupted outward. And when you look at the cosmic background radiation, the faint glow left from the earliest moments, you see a near-perfect smoothness, a uniformity that shouldn't occur by chance but makes sense if the entire universe began from a region smaller than an atom, compressed and then inflated during its escape from the collapse. This perspective also reframes dark energy, the mysterious pressure driving galaxies apart. Instead of being an enigmatic force with no explanation, it could be the lingering effect of the rebound, an imprint of the violent expansion that launched our universe. It might even be the natural tendency of spacetime inside a black hole, an inherent drive toward outward growth once collapse transitions into expansion. And if that is true, then the fate of our universe is already written by the physics of the black hole we emerged from, meaning our long-term future, whether we expand forever, slow down, or eventually contract, depends not only on our own internal energy but on the mass, rotation, and charge of the parent black hole itself. In a sense, we are living inside a fossil of another universe's death, a cosmic echo of its final collapse, yet also the beginning of something new. And if every black hole produces a universe, then the cosmos may be far larger than anything we can imagine. An endless tree of universes branching from one another, each with its own history, its own physics, and perhaps even its own forms of life, all hidden away within the depths of black holes we will never see from the outside. And as we follow this path further, the structure of reality begins to resemble a vast, ever-growing network of universes rising from the gravitational collapse of those that came before, a continuous chain where every endpoint becomes a beginning and every beginning is born from unimaginable pressure and darkness. In this picture, our universe isn't a singular creation but one link in a lineage that may stretch back for ages beyond comprehension, each generation shaped by the physical traits of the black hole that produced it. The spin of that parent black hole could determine the overall motion of galaxies. Its mass could influence the density of matter. Its magnetic fields might leave subtle fingerprints on the earliest light. And this inheritance means that the variations we see across the cosmos, voids, clusters, filaments, and waves, could be the faint signatures of a collapse we never witnessed, written into the fabric of spacetime long before there were stars to read it. It also means that somewhere out there, hidden behind the walls of our own horizon, lies a larger environment we will never access, a universe that lived and died to give rise to ours, filled with galaxies we will never see and histories we can never uncover. And if each universe contains countless black holes, then each one may birth countless children, forming an endlessly branching structure that grows exponentially with every generation, more like a forest than a singular cosmos. In such a system, universes capable of producing many black holes effectively reproduce more successfully, creating more descendants and passing on their physical characteristics. This would mean that the universes most likely to exist are the ones with laws of physics that maximize black hole formation, which just so happen to be the same laws that create long-lived stars, stable atoms, and environments where life can arise. In other words, we might not be here because the universe is tuned for life. We might be here because the universe is tuned for black holes, and life is simply an unexpected byproduct of those same conditions. And as unsettling as it sounds, this view gives our existence a quiet place within a cosmic pattern far larger than ourselves. Not an accident, not a miracle, but a small, inevitable outcome inside a universe shaped by generations of cosmic evolution. And when you start to picture this immense structure of interconnected universes, each one budding from the collapse of another, you begin to understand that our entire cosmic perspective may be limited not by imagination but by the boundaries of the space-time bubble we inhabit, because if we truly live inside the interior of a black hole, then the physics we treat as universal might be nothing more than local rules specific to our cosmic pocket, rules that shift from one universe to the next the way climates change across continents. In some universes, gravity might be too strong, causing matter to clump into dense islands of star-sized objects before life has a chance to form. In others, gravity might be too weak, leaving matter so dispersed that stars never ignite and darkness reigns forever. There could be universes where time flows differently, where particles behave in unfamiliar ways, where energy moves in patterns incompatible with what we call matter, and from the outside looking in, if an outside even has meaning, our universe might appear just as strange, a glowing bubble expanding within the event horizon of a long-dead star that existed in a cosmos we can never know. And this makes the question of origins even more profound, because instead of asking where our universe came from, we must ask where the first universe in this sequence came from, or if such a first ever existed at all. Perhaps the chain extends infinitely backward, with no true beginning, each generation born from the remnants of the one before, forming an eternal cycle of collapse and rebirth that has been running long before our own Big Bang. If that is the case, then our search for a singular moment of creation, an absolute starting point, may be misguided, because the universe could be part of a process with no starting line, no fundamental birth, just endless transitions from one form to another. And yet, even if we are sealed inside a black hole universe, even if we are cut off from the parent cosmos forever, the clues of our origin may still be embedded in the fine structure of our physical laws, in the shape of space-time, in the ripples of the cosmic background radiation, in the uniformity that suggests something smoothed our universe before the earliest detectable moments. Every measurement we take, every particle we study, every distant galaxy we observe could be a faint whisper from the collapse that produced us, a subtle reminder that our universe was not born from nothing but from a transformation so violent and complete that it left only physics, and the space we live in as its residue. And this idea, strange as it seems, gives a new meaning to our place in the cosmos, because instead of floating in a cold void without purpose, we become inhabitants of a universe shaped by forces beyond imagination, part of a lineage older and larger than anything we could ever witness, living inside a structure that once was the heart of a massive star in a universe now forever beyond our reach. And as we let this possibility settle, that everything we know, from the smallest atom to the largest supercluster, exists within the stretched, distorted interior of a collapsed star, it forces us to rethink what it actually means to observe the universe at all, because every telescope we build and every signal we detect is ultimately limited by the curvature of spacetime inside this cosmic chamber, shaped not only by the expansion that followed our birth, but by the lingering geometry inherited from the collapse itself. This means the cosmic horizon, that vast boundary beyond which nothing can be seen, might not be the true limit of the universe but the imprint of the event horizon we were born within, a frozen surface that prevents us from ever knowing what lies outside or what kind of universe existed before ours emerged. Even the uniformity of the cosmos, the way distant regions look almost identical despite being separated by unimaginable distances, could be explained if everything originated from a single, compressed core that inflated rapidly after the bounce, spreading matter and energy so evenly that the entire visible universe became one smooth, balanced structure. And if we look closer at the behavior of space-time on the largest scales, we see that galaxies don't merely drift apart. They accelerate away from each other, as if pushed by an unseen force. This force, which we call dark energy, might simply be the natural expansion tendency of a universe born from gravitational rebound, the lingering effect of a moment when collapse shifted into explosive growth, a transition so extreme that its influence still guides the motion of galaxies billions of years later. In this view, dark energy becomes not a mystery but a memory, the aftershock of our cosmic birth. And if this expansion continues indefinitely, the universe will grow colder and emptier, stars will fade, galaxies will thin out, and everything will drift toward isolation as the interior of this black hole universe stretches further and further. Yet even in that distant future, long after the last star dies, the universe would still carry the imprint of its origin, because space-time itself, a fabric shaped by the collapse of a parent star, would persist, expanding endlessly, holding within it the subtle clues of the moment when everything began. And somewhere deep within that vast emptiness, future observers, if any form of intelligence survives the slow fade of light, might wonder about their origins just as we do now, unaware that they, too, are living inside a structure born from a collapse in a universe long vanished, part of an eternal chain of creation with no beginning, no end, and no final truth that can ever be fully reached from within. And if we follow this line of thought to its furthest edge, we begin to realize that the very act of looking outward, of scanning the sky for distant galaxies, of measuring the faint glow of ancient radiation, of mapping the cosmic web, is really an attempt to read the internal structure of a black hole from the inside, like trying to understand the shape of a cave by studying the echoes of your own voice. Every observation we make is filtered through the curvature of space-time created at our birth. Every photon we detect bent, stretched, or redshifted by a geometry we inherited and cannot escape. Even the shape of galaxies, the clustering of matter, the distribution of energy, all of it may reflect the spinning collapse that produced our universe, giving us clues not just about our own cosmic history but about the universe that came before. And when we observe the large-scale structure, the way galaxies form long filaments separated by vast voids, we may be witnessing the internal dynamics of that collapse, the subtle fingerprints of rotation, momentum, and turbulence frozen into place during inflation. In this sense, the cosmos becomes a kind of fossil, not a relic made of bone or stone, but a record of forces so immense and ancient that they left impressions carved into space-time itself. And our attempts to find a unified theory, to connect quantum mechanics with general relativity, to understand why particles behave the way they do, might be less about solving an abstract puzzle and more about deciphering the conditions inside the black hole that birthed us. Perhaps the strange rules of the quantum world, the way particles flicker between possibilities, the way they refuse to settle into fixed states, are remnants of the extreme pressures and compressed geometries that once defined the earliest moments of our universe. Maybe the uncertainty we see in the smallest scales is a memory of the impossible density that once squeezed all matter into a point, a leftover feature of a time when space-time itself was unstable and shifting. And if this is true, then every scientific theory we test is not only a model of our universe but a map of the interior of that ancient collapse, a way of reconstructing a cosmic event we can never witness directly. It also means that our understanding will always be partial, because the full story of our origin lies beyond the horizon, sealed away in a region of space-time permanently cut off from us. Yet even if we can never see the parent universe, its influence surrounds us in every direction, written into the laws that govern particles, the forces that shape galaxies, and the constants that allow stars to shine. In the end, we may never step outside the boundaries of this black hole universe, but through careful observation and relentless inquiry, we can read its structure from within and trace the faint whispers of a cosmic ancestry deeper and older than anything our species was ever meant to witness. And as this idea settles into the fabric of our understanding, it forces us to confront a profound truth. If our universe is the internal structure of a black hole, then the very concept of space as we experience it is not a universal medium but a temporary environment shaped by the conditions of our cosmic birth, a region defined by the way space-time stretched and expanded after that first instant of transition. Everything we call the universe might simply be the volume inside our own event horizon, inflated to unimaginable scale, while the true exterior remains forever hidden behind a one-way boundary we cannot penetrate. This turns the familiar into something far stranger because even the passage of time, something we take as a natural flow, is a product of this interior geometry, running differently near massive objects, slowing near black holes, and behaving in a way that hints at a deeper truth. Time inside a black hole is fundamentally different from time outside it. If our universe began as the interior of such an object, then our perception of time, our cosmic history, even the arrow that points from past to future could all be shaped by that origin. And when cosmologists look back toward the Big Bang, reaching for the earliest signals still drifting through space, they find a wall of opacity where light can no longer pass, a haze of ancient plasma that blocks all information from before a certain moment. Beyond that, we find silence, a complete absence of data, as though the universe is refusing to show us what came earlier. To many, this is simply the limit of measurement. But in the black hole model, it becomes something else. The imprint of a horizon, the last boundary beyond which information is sealed. What we interpret as the earliest glow of creation might instead be the inner memory of that boundary, blurred and stretched by expansion, the remnant of a moment when collapse reached its peak and reversed into growth. Even the distribution of fluctuations in the cosmic microwave background, those faint irregularities that seeded all galaxies, carries the pattern of a sudden, violent transition, one so abrupt that it resembles not a gentle emergence but a rebound from a state of near-infinite density. These ripples, tiny as they are, may be the only surviving clues of the parent universe's collapse, hints that something once pressed inwards with unimaginable force before releasing everything outward in a burst of expansion we still measure today. And so, the deeper we look into the sky, the more it seems that the universe is not a freely created space but the interior of an event that occurred beyond our sight, a cosmic transformation whose final moments shaped everything we now observe, leaving behind a structure so vast and so uniform that only a black hole's interior geometry can explain it. If this is true, then the night sky becomes more than a window into space. It becomes a map of an ancient collapse, frozen in time, stretched across billions of light years, its echoes embedded in every galaxy, every star, every particle, and every second that passes. And yet, even as we imagine our universe nestled inside a cosmic black hole, we must confront the most profound consequence of all. If black holes create universes, then the multiverse is not a chaotic sea of random possibilities, but a family tree of cosmic evolution, with each generation shaping the next through the physics encoded in its singularity. Our universe may have inherited its physical constants, the strength of gravity, the charge of the electron, the mass of fundamental particles, from the black hole that birthed it, just as a child inherits traits from a parent, not by intention but by the natural constraints of cosmic reproduction. This leads to one of the most extraordinary implications of the black hole universe hypothesis. Universes that produce more black holes become more successful in propagating their physical laws forward, meaning our universe may be fine-tuned not for life, but for black hole production, with life emerging as an accidental passenger in a cosmos optimized for gravitational collapse. If true, this reframes everything we know. Stars are not simply brilliant furnaces of light, but the reproductive engines of universes. Galaxies are not just cosmic cities of matter, but the scaffolding upon which new universes are seated. And black holes are not the dead ends of physics but its continuation, its renewal, and its expansion into realms forever beyond our observational reach. But even as this grand evolutionary cycle unfolds, we remain trapped inside the event horizon of our own cosmic parent, unable to see beyond the boundaries that define our existence, unable to confirm whether our Big Bang was truly a singularity or merely the other side of a collapse in a higher reality, and unable to know whether the black holes we observe are themselves generating newborn universes with their own physical laws, galaxies, stars, and civilizations asking the same questions we ask now. It is a humbling, almost dizzying idea that every black hole in our universe might contain an entire cosmos swirling within it, that every universe may be the interior of some deeper structure, and that the multiverse might be an infinite nested hierarchy of realities, each spiraling outward and inward without beginning or end. And if this is true, then the meaning of our existence is not found in our small corner of space, but in the fact that we are part of a cosmic lineage stretching across unimaginable scales. a single consciousness awakening inside a universe that itself is the child of something far older and far stranger. A universe born in darkness, expanding toward light, and carrying within it the seeds of countless worlds yet to be born. And as we push deeper into this possibility, another profound question emerges. If our universe was born inside a black hole, then the moment of our own creation was not an explosion from nothingness, but a transformation. A collapse of space-time in a parent universe that funneled matter, energy, and information through a singularity, stretched it, rebounded it, and released it as the expanding cosmos we now inhabit. This means that the Big Bang, long believed to be the beginning of everything, might instead be a bridge between realities, the inner heartbeat of a multiverse that continuously renews itself through gravitational collapse. In this view, every universe is both a descendant and an ancestor, linked through black holes like branches in a cosmic family tree. But if that is the case, then we must accept an idea even more unsettling. The laws of physics inside a black hole are not broken. They are simply rewritten for the new universe forming within, meaning the constants we measure, from the speed of light to the curvature of space to the quantum rules of matter, may be the inherited traits of a universe optimized by evolution across countless generations. This is not randomness nor design. It is selection, physics adapting through the fertile chaos of black holes. And as our telescopes peer across billions of years of cosmic history, seeing light from galaxies born when the universe was almost too young to form them, we may actually be witnessing the fingerprints of that deeper ancestry, subtle clues that our early universe was shaped by conditions encoded long before the Big Bang itself. Even the mysterious uniformity of the cosmic microwave background, the smooth afterglow of creation, starts to resemble the kind of perfect reset that would occur if all the matter of a previous universe were compressed into a single point before rebounding into expansion. And if this is true, then we are left with an extraordinary realization. The boundaries we perceive as the edge of our universe may not be edges at all, but membranes shielding us from a reality we can never reach, just as the event horizon of a black hole hides everything within from the outside world. In the end, we may be living inside the greatest gravitational illusion of all time. A universe born inside a cosmic shadow, expanding with purpose, carrying forward the echoes of a world that collapsed long before the first atoms formed, and destined to one day create new universes of its own when its stars die, its black holes awaken, and the cycle begins again. And as we travel further into this idea, the concept of identity itself begins to unravel, because if our universe is a child born from the death of another, then everything we witness, every galaxy, every law, every force, might be a residue of a previous cosmic lifetime, carried across the event horizon like genetic memory. Even time, which we treat as a rigid arrow pointing forward, may simply be a local rule that emerged as our universe cooled and stretched into its current shape. Inside a black hole, time behaves nothing like it does here. It slows, it warps, it twists so dramatically that cause and effect nearly fall apart. Yet from this chaos, a new timeline could emerge, smooth and linear, giving rise to a universe that feels ordered even though it was born from absolute distortion. And when we observe the massive black holes at the centers of distant galaxies, ancient, monstrously heavy, forming in impossibly early moments of cosmic history, we may be seeing more than collapsed stars. We may be seeing the seeds of universes not yet born, each one a womb of space-time waiting for its internal physics to stabilize into something new. If consciousness ever arises in those universes, if life ever looks up to their skies and asks how everything began, they might never know that their entire reality started inside a gravitational boundary in a universe that has long vanished. And perhaps we, too, are living inside someone else's forgotten collapse, a cosmic echo left drifting in an infinite cycle of creation and destruction where universes bloom like flowers, die like stars, and leave behind black holes that act as portals to realms we can never escape to or from. Even the strange acceleration of our universe, driven by dark energy, could be a remnant of a previous universe's final expansion. a kind of inherited momentum pushing ours outward faster and faster, as though the last breath of a dying cosmos became the first heartbeat of ours. If this cascading lineage of universes is real, then we are not living at the beginning of creation but somewhere in the middle of a grander, older, endless process, a universe inside a universe inside a universe, stacked like cosmic Russian dolls stretching deeper than imagination allows, each one carrying traces of the one before it, each destined to collapse, rebound, and evolve again. And so, as we reach the edge of this idea, the possibility that our entire universe is nothing more than the interior of a black hole inside a larger, older reality, we arrive at a strange kind of peace, because this theory does not shrink our significance. It expands the stage on which existence unfolds. It means that every star, every spiral galaxy, every atom in your body is part of a chain of cosmic inheritance stretching beyond any single beginning, tied to ancestors we will never know and descendants we will never meet. It means that the violence of a collapsing star might not be an ending but a transition, a transformation from one universe to the next, like a seed cracking open to reveal the first breath of a forest. And if our universe is a chapter inside a much greater book, then the story of existence is not defined by one big bang or one final collapse, but by an eternal rhythm. Expansion, contraction, renewal, rebirth. Perhaps the larger universe outside our black hole boundary is filled with civilizations who have asked the same questions, looking at their own skies, wondering if they too were born inside a collapse they can never see. And one day, far in our future, when every star has burned out and every trace of light has faded into a whisper, our universe will contract into darkness and fall back on itself, returning to the same kind of singularity that once gave birth to us. A moment of unimaginable pressure where the fabric of reality twists into a boundary no observer can escape. But that will not be a tomb. It will be a cradle. From our final collapse, another universe will ignite, carrying fragments of our physics, our constants, our structures, our hidden fingerprints, and maybe even echoes of our existence. We will become the ancestors. We will become the forgotten past of a cosmos yet to be born. And the cycle will continue, endlessly, silently, beautifully. A universe in a black hole in a universe, creation inside destruction, beginnings hidden inside endings, forever spiraling through infinity.